Hi guys, what's up? Welcome to my YouTube channel. I welcome you to another episode of Learning Physics with IBM. This is my contact. If you have any question, if you have any problem, if you need any resources that you think I can provide, please always contact me on that email. I'll always help where possible. A friend of mine has asked me to record a video about paper 3 practicals. I'm going to use one of the results of my students, and I try to explain how to approach practicals. So after force density and pressure, I'll record at least a few practicals before I go to kinematics and dynamics. So without wasting time, let me take you to part 10 of solved past paper questions, force density and pressure. So this is where we stopped on in part 9. We stopped on this page here. Actually, we stopped on this question here. So we had agreed that the answer was D, that if the weight is moved further to the right, then for no toppling or to maintain equilibrium, the center of gravity must slightly shift to the same side, so that it's like the distance of the weight W from the left to the center of gravity should be slightly increased so that there's no toppling. Okay, so I want us to start with this question here. At room temperature, the density of liquid mercury is 5 times greater than the density of solid aluminium. That is at room temperature. What is the reason for this? What is the reason for this? So we know that density is mass over volume. Density is mass over volume, and they are telling us the density of mercury is equal to 5 times the density of aluminium. So what is the reason for this? Let's check this by inspection. Aluminium atoms are spaced widely. Aluminium atoms are spaced widely. The density of mercury is 5 times greater than the density of aluminium, the density of solid aluminium. So this one is not correct when we say, because mercury is in malt is liquid and aluminium is solid, so you can't say aluminium atoms are spaced widely, yet it is solid, so that is not true. Aluminium atoms move freely than mercury, yet it is solid. No, that is not true. Atoms in a liquid take up less space than atoms in a solid. That is not true. Atoms in a liquid take up actually more space because they are free to slide past each other. So this is not true. So it means the answer is going to be automatically D. Mercury atoms have greater mass than aluminium atoms because density is mass over volume. So we can say mercury atoms have greater mass than aluminium atoms. Okay. A pipe is closed at one end and contains gas trapped by a column of water. Okay. The atmospheric pressure is 1.0 times 10 power 5 pascals. The density of water is 1,000 kilograms per meters cubed. What is the pressure of the gas? So, of course, the pressure of the gas here, because the other side is open and we see that the level of liquid on the right-hand side is higher, it means the gas is at a higher pressure. So if I want the pressure of the gas, then it should be the atmospheric pressure because the open end is at a higher level. So it means the pressure of the gas is above the atmosphere, is above atmospheric pressure by a value which is given by H rho G. So that is going to be the pressure of the gas. So the atmospheric pressure is 1.0 times 10 power 5 pascals, and H is going to be 5 times, of course H will not be 7, it will actually be 5. Then times density, which is 1,000, then times G, which is 9 point. They said use G as 10, so G is going to be 10. So I'll check my calculator. 5 times 1,000 times 10, then plus 1.0 exponent 5. So this is 1,000, this is 150,000, 150,000 pascals. So here it means the answer is going to be C. A hailstone, initially stationary at the base of a cloud, falls vertically towards the earth. The diagram shows the magnitudes and directions of the forces acting on the hailstone as it starts to drop. So the weight, the upthrust, and the viscous force. So as it starts to drop, the viscous force is small, but as it drops, of course, the viscous force is like friction, which increases with the speed. So this one must increase. Um, the weight will not change, it remains the same length. So let's check that the weight has remained the same length. Okay, the weight has remained the same length. Which diagram shows the magnitude? Which diagram shows the magnitude? The magnitudes and direction of these forces when the hailstone attains a terminal velocity. Of course, when we reach terminal velocity, acceleration is 0, resultant force should be 0. That means when I add the upthrust to the viscous drag, because the viscous, since it is falling, the viscous drag is going to increase, is going to be in that direction. So since when we add the 2 viscous drag plus the upthrust, should give us the weight. The weight should be equal to the viscous drag plus upthrust. Okay, so let's check. This one is automatically wrong because as it falls, we expect air resistance to increase. The viscous drag must increase. So this one is wrong. It is showing that the viscous drag does not change. Then B is also wrong because as it falls, upthrust remains constant because upthrust is cross-sectional area times difference in pressure, which is cross-sectional area times density times g times difference in height. So the difference in pressure on the top and the bottom of the object remains constant if the object is fully submerged. So the upthrust should also remain constant. So this means B is wrong. C is also wrong because it shows that the upthrust has increased. The upthrust should remain constant. Look at the length representing the upthrust. This is the magnitude of the upthrust. The length of that line should remain the same. So it means C is also wrong. So the answer is going to be D. The upthrust does not change. The weight does not change. It is V which increases. But note that when you add this line here of V, the line of upthrust, you should be getting the length of the weight, but in the opposite direction. So the answer is going to be D. Diagrams show the forces acting on different bodies. Which diagram cannot be in equilibrium? Which diagram cannot be in equilibrium? Okay, so we can check first. The simplest way to check this is to see if the 3 forces can meet at the point and they can act in the same point. So to check, I will prolong these forces to see if they can meet at the same point. If they don't meet at the same point, then it means they can never form a closed triangle. So they can't be acting on a body in equilibrium. So if I try to prolong them with a ruler, of course, these ones are not going to meet at the same point. So it means when we draw them to scale, they will not form a closed triangle. Let me check this one at B. Okay, so these ones can meet at the same point. So that one is, there's equilibrium here. Let's check C. So this one, there is equilibrium. Let's check D. Of course, D, they are already acting at the same point, so there is it is possible to have equilibrium. So this one, this C and B, they are in equilibrium. So this one, they cannot be in equilibrium. So the answer is A. The diagram shows a rectangular block of mass 8.2 kilograms immersed in seawater of density 1.10 times 10 power 3 kilograms per meters cubed. What is the difference in pressure between the top and bottom of the block, difference in pressure. So we know that pressure due to a liquid is equal to H density times G. So difference in pressure is going to be density times G times difference in height from the top and the bottom. So precisely this is going to be density, which is 1.1 times 10 power 3, then times G, which is 9.81. Difference in height is going to be 2.2 minus 2. So this is going to be 1.1 exponent 3 times 9.81 times 2.2 minus 2 is 0.2. So this gives us 2158.2 pascals. So let's check the answers here. So the answer is going to be C, 2.2. When I move 1, 2, 3 steps, 2.2 times 10 power 3 pascals. So the answer is B. A mass of 2 kilograms rests on a frictionless surface. It is attached to a 1.0 kilogram mass by a light thin string which passes over a frictionless pulley. The 1.0 kilogram mass is released and it accelerates downwards. Okay. What is the speed of the 2 kilogram mass as the 1 kilogram mass hits the floor? As the 1 kilogram mass hits the floor. Okay, so I am going to just simply come up with two equations here, and I try to solve them. So considering mass, I'm going to begin by considering this because the acceleration is in this direction here. So resultant force MA is going to be equal to 1 times G, which is 9.81. Then there is tension, of course, in the opposite direction. So this is going to be minus T. So M is 1, so I will say 1 times A, which is simply A, equals to 9.81 minus T. This is going to be equation number 1. Then I will consider this mass. Of course, the tension is going to be in this direction here. This is the tension. The tension pulls away from the object, and the acceleration is in that direction there. So for this mass here, the tension T is the only force acting because it is moving horizontally. So the tension T, or I will simply say the mass, which is 2 times the acceleration, which is A, is equal to the tension T, because T is the only force which is acting there in the horizontal. So this is going to be equation number 2. So when I substitute, or when I solve these two equations, I'll have that, or I substitute for T. So this means that A is equal to 9.81, where there is T, I'm putting 2A. So what does this mean? It means that 3A, so 3A is equal to 9.81. So I'm going to press my calculator to get A. So 9.81 divided by 3. So this gives us 3.27. So the acceleration is 3.27 meters per second squared. So what is the speed of the 2.0 kilogram mass as the 1.0 kilogram mass hits the floor? So we now want to find the speed. So I'll use equations. Since the acceleration is constant, I'll use equations of equations of uniformly accelerated motion, such as v squared equals to u squared plus 2as. So v squared is going to be equal to, if it starts from rest, because 2 kilogram mass is going to start from rest, since they said a mass of 2 kilogram rests on a friction surface. That means u is 0, so this is going to be 0 squared plus 2 times the acceleration, which is 3.27, then times, Of course, when the 1 kilogram mass hits the float, it would have moved through a distance of 0.5. It means the 2 kilogram mass also moves through the same distance horizontally. So this is going to be times 0.50. So this is going to give us V. So 2 times 3.27 times 0.5. Then I find the square root. So this is giving me 1.8. So this is 1.8 meters per second. This is V after finding the square root. So the answer is going to be A. The diagram shows an experiment to measure the force exerted on a ball by a horizontal airflow. The ball is suspended by a light string and weighs 0.15 newtons. The deflection of the string from vertical is 30 degrees. What is the force on the ball from the airflow? Okay. So first of all, the ball has a weight which acts vertically downwards, and this is 0.15 newtons. And the airflow is in that direction there. So the question is, what is the force on the ball from the airflow? So I am going to resolve, there is of course tension here, and I will resolve this vertically and horizontally. So if I draw a vertical line, this angle is going to be 30 degrees. There is tension here. Resolving T in the horizontal, in the vertical, it is going to be T cos 30 in the vertical. So T cos 30 in the vertical should be equal to 0.15 in the vertical, because T cos 30 in the vertical points upwards. This is T cos 30. And then in the horizontal, T in the horizontal will point in this side to overcome the airflow or to overcome the air resistance. So this, when I resolve T in the horizontal, it will be T sine of 30. So in the horizontal, T sine of 30 should be equal to the force due to the airflow. So the question wants us to find the force due to the airflow. So I'm going to divide the two equations. So T sine of 30 divided by T cos of 30 should be equal to the force due to the airflow divided by 0.15. I divided the two equations, so T cancels out. So it means the force due to the airflow is going to be tan 0.15 tan of 30. So I have 0.15 tan of 30, and that is 0.087 newtons. So the answer is going to be B. A student balances a 30 centimeter ruler on a fulcrum set at the 15 centimeter mark. She then places 50 grams mass on the 23 centimeter mark and the 20 gram mass on the 11 centimeter mark. It is a 30 centimeter ruler, remember, 30 centimeters. And as shown, which mass should she place on the 7th mark to restore the balance? Okay, we're just going to take moments. I'll not change the units of mass. I'll not change to kilograms. So we just find the perpendicular distance. This is because it is pivoted on the 15 centimeter mark, that is at the midpoint. So this is 15. So this distance is going to be 15 minus 11, which is going to be 4 centimeters. This distance is going to be 23 minus 15, which I think is 8 centimeters. Then this distance here is going to be 15 minus 7, which I think is also 8 centimeters. Okay, so clockwise moment should be equal to anti-clockwise moment. So I'll simply say 50 grams times the perpendicular distance, which is 8, that is clockwise, should be equal to anti-clockwise. We have 20 times 4 plus a certain mass m or a certain mass x times 8. So I'll just check with my calculator. 50 times 8 minus 20 times 4 divide by 8. So I'm getting this as 40, so x is equal to 40. So my answer is going to be B. A sledge slides down a slope at a constant velocity. Acceleration is 0. The three forces that act on the sledge are the normal contact force C, the weight W, and the friction force F. So it is sliding down a slope. So let me sketch a slope. Let's say this is the sledge sliding down a slope. So it has weight vertically downwards, and the normal contact force, and of course frictional force should be the other way around. Okay, which diagram represents these forces acting on the sledge? Of course, the weight must be vertical downwards. That is fine. Since it is at a constant velocity, acceleration is equal to 0. The resultant force should also be 0. And this should form a closed triangle. Because there should be equilibrium, so this should form a closed triangle. So we need a closed triangle. So let's first check if they are all closed triangles. So if I move, of course this is not closed because we have weight vertical downwards, then C is in that direction, but then F is the other way around, so it is not closed. It's not completely closed. It is showing like W plus C is equal to F. This is what it means. Yet W plus C plus F should give us 0. So this one is showing W plus C plus F. So it is also not closed. So we shall ignore this one. This is showing W plus F plus C. So this is a closed triangle because we can move around the triangle in an anti-clockwise direction. So the answer is going to be C. This one is showing W plus F. Then it is showing C in the opposite direction. So this is not closed. So the answer is automatically C. We need a closed triangle. For constant velocity, acceleration is 0. Resultant force is 0. We have equilibrium. So we must have a closed triangle. A 1.2 kilogram mass is supported by a person's hand and 2 Newton meters as shown. When the person's hand is removed, what is the initial vertical acceleration of the mass? When the person's hand is removed, what is the initial vertical acceleration of the mass? Okay. So first of all, we are going to find, let's first find the mass. The mass is going to be 12 divided by 9.81. That is the mass. Let me check. 12 divided by 9.81. That is 1.22. So this is 1.22 in kilograms. That is the mass. Now let's try to find the resultant force. We have to resolve these ones vertically upwards. There's tension here, there's tension here. And according to the reading, the tension here is going to be 4 newtons. The tension here is going to be 3 newtons. So we need the components of these tensions. This is 3 newtons, this is 4 newtons. So resolving vertically upwards, we shall have for 4 newtons in the vertical using 37, that would be 4 cos of 37. And then for 3 newtons, that would be 3 cos of 53. So if there is a resultant force and it moves downward, so it means the resultant force, I'll use R for resultant force, is going to be 12 minus the total force upwards, which is 4 cos of 37 plus 3 cos of 53. That will give us the resultant force. So let's check this. 12 minus open brackets 4 cos 37 plus 3 cos 53. So I am getting the resultant as 7.0. So the resultant is 7.0 newtons. So now I want to find the initial vertical acceleration. So from Newton is second law, F is ma. So the acceleration will be the resultant force, which is 7, divided by the mass, which is 1.22. So I'll just divide that by 1.22, and I get 5.7, which is approximately 6. So this is approximate 5.7, which is approximately 6. So the answer is going to be D. A stationary body floats in water. Which statement about the forces acting on the body is correct? It is stationary. So it means, of course, viscous drag is friction, but the body must be in motion. So the gravitational force is equal to the viscous force. There is no viscous force here because the body is not in motion. Since it is not in motion, there is no viscous force. So there is no, that means A is wrong. The gravitational force is greater than the upthrust. If the weight is greater than the upthrust, the body must sink deep into, the body will sink down to the bottom. Then the gravitational force, sorry, this is wrong. The gravitational force, which is the weight, this is the weight. It is not greater than the upthrust. Otherwise, the body would sink to the bottom. Then the upthrust is 0. No, it can't be 0. The upthrust is not 0. If the upthrust is 0, then the body will just be floating. No, if the upthrust is 0 still, it means the weight is greater than the upthrust. The body will sink to the bottom. Then the viscous force is 0. This is correct because there is no motion. No motion. Viscous force is like friction. Friction is going to be considered only when a body is tending to move or it is in motion. So the answer is D. The viscous force is 0 because there is no motion. A rigid uniform beam is pivoted horizontally at its midpoint. Different vertical forces are applied to different positions on the beam. In which diagram is the beam in equilibrium? Okay. So we are going to check, let me start with A. So this is causing a clockwise moment, anti-clockwise moment, and this is also causing anti-clockwise moment. So this is not in equilibrium because there is a resultant anti-clockwise moment. Even though the resultant force is 0, there is a resultant anti-clockwise moment, so there is a rotation anti-clockwise. For equilibrium, the resultant force should be 0 and the resultant moment should be 0. Here the resultant force is 0, but the resultant moment is not 0. Let's check B. This is clockwise, anti-clockwise, and this is clockwise. But you notice that this is 4 times 15, and this is 5 times 10. First of all, the resultant force is not 0. It is going to be 10 newtons downwards, unless there is an equal but opposite force acting here in the opposite to balance this one, which will be the normal reaction. But then if we ignore the resultant force, the torque is not 0, because on the clockwise moment is 10 by 5, which is 50, and the anti-clockwise moment is 15 by 4, which is actually 60. So it means there is a resultant which is anti-clockwise. So this is not in equilibrium. Then we can check C. The clockwise moment is 14 by 5, which is 14 by 5, that is 28, that is 56 Newton centimeters. This is clockwise. Anti-clockwise, we have 5 by 2, which is 10, and we have 15 by 4, which is 60, so 10 plus 60. I hope I'm calculating correctly. On the left, it is 5 by 14, that is 70, not 56. Then on the right, that is on the right. On the left, we have this is anticlockwise, 10 plus 60, which is 70 Newton centimeters. So clockwise is equal to anticlockwise, so there is equilibrium here. If we check this one, 15 by 5, 15 by 5, 75. This is the clockwise 75 Newton centimeters. Anticlockwise, we have this is going to be 25 plus 5 times 5 is 25, which is 50 Newton centimeters. This is going to be anticlockwise, so this is not in equilibrium. So the answer is C. 70 Newton centimeters anticlockwise, 70 Newton centimeters clockwise. So the answer is going to be C. A picture on a wall is supported by a wire looped over a nail. The mass of the picture is 4.2 kilograms. What is the tension in the supporting wire? So if the mass is 4.2 kilograms, it means there is a weight. There is a weight which is acting, let's say, from the center of the picture, vertically downwards, which is going to be 4.2 times 9.81. That is going to be the weight. So when there is tension in these wires, and the tensions T must be acting vertically upwards, must be acting away from the picture. So we are going to resolve the tensions upwards. So resolving T upwards here, it is going to be T sine of 25. Even here it will be T sine of 25. So it means 2 times T sine of 25 for equilibrium should be equal to 4.2 times 9.81. Total forces upwards should be equal to total forces downwards. So what is T? I'll just check with my calculator. 4.2 times 9.81, then divide by, open brackets, 2 sine of 25. So it means T is going to be equal to 48.75 or approximately 49 newtons. So the answer is going to be C. A cable car of weight W hangs in equilibrium from its cable at point P. The cable has tensions T1 and T2 as shown. Which diagram correctly represents the forces acting at point P? So of course there is weight downwards. So the tension in that direction, we can first of all try to predict which one could be possible. So the weight vertically downwards, the tension in that direction, this is T1, and then without changing the direction of T2, T2 should be in that direction, so this should be meeting. That is one way of doing it. Alternatively, we can put them on the left hand side. Yes, we can put them on the left hand side. So let's check the possibilities. Remember, for equilibrium, they should form a closed triangle. Let's check. Let's begin by inspecting the closed triangle, if they are closed triangles. So if I start with the weight moving anticlockwise, you notice that T2 is in the opposite direction. So this is not a closed triangle. If I start with the weight moving anticlockwise, I can come back to the same position. So this is a closed triangle. The answer is automatically going to be B. I don't need to check because the directions of the tensions, let me check if the directions of the tensions have been reversed. Not at all, because T1 points away from the object, T2 also points away from that one. So it means this is the correct diagram. I will not check the rest. The diagram shows 4 forces applied to a circular object. Which row describes the resultant force and resultant torque on the object? So in the vertical, the resultant is 0. In the horizontal, the resultant is 40 newtons to the right. So the resultant force is not 0. Resultant force is non-zero. Let's check the resultant torque. This causes a clockwise torque. This causes an anti-clockwise torque, which is cancelled out. But these 30 newtons caused a clockwise torque, which is So 20 newtons and 20 newtons will cause, this causes clockwise. This is anti-clockwise. They cancel out each other. So these ones cancel out each other. But this one causes clockwise and this one causes clockwise. So they add up. The resultant torque is not zero. So this one is also wrong. So it means our answer is going to be D. The resultant force is not zero. The resultant torque is not zero. It is going to be the product of one of the 30 Newton force and the perpendicular distance between them, because they are forming a couple. A 1.5 meter cubed of water is mixed with 0.50 meter cubed of alcohol. The density of water is 1000 kilograms per meters cubed, and the density of alcohol is 800 kilograms per meters cubed. What is the density of the mixture with a volume of 2.0 meters cubed? Okay, so I hope this is 1.5, if not 1.3. I will use 1.5. So we know that density of a mixture is going to be total mass divided by total volume. So what is the total mass? They said 1.5 meter cubed of water is mixed with 0.5 meters cubed of alcohol. We know the total volume, but we don't know the mass. We know that mass is going to be density times volume. So I'm now finding total mass for water. It is going to be 1.5, or density times volume, 1000 times 1.5. That is the mass for water, plus for alcohol it is going to be 0.5 times the density of alcohol, which is 800, divided by the total volume, which is 1.5 plus 0.5. That is the total volume. I think this is 0.5, and I think this is 1.5. Okay, so I'll press my calculator and check. 1000 times 1.5 plus 0.5 times 800 divide by 1.5 plus 0.5. I think that is 2. So dividing by 2, I'm getting 950. So this is 950. So the answer is going to be D. The diagrams all show a pair of equal forces acting on a meter rule. Which diagram shows forces that provide a couple and zero resultant force? A couple, these are two equal but opposite forces whose lines of action will never meet. This is not a couple. This is not a couple because their lines of action are meeting. And let's check. This one is, if I prolong this line, it will meet the other one. So this is not a couple. So the answer is automatically B. They are forming a couple and zero resultant force. That means the magnitude of this line, the length of this line and this line are the same. So the magnitude is the same. So they are cancelling out. So the answer is automatically B. The lines of action never meet. Lines never meet. For a couple, the lines should never meet. That's why I said C is wrong, D is wrong, because lines never meet. Then they should also be opposite, in opposite direction. That's why I said A is wrong. So that's not a couple. A uniform rod XY of weight 10 newtons is freely hinged to a wall at X. It is held horizontal by a force F, acting from Y at an angle of 30 degrees to the horizontal as shown. What is the value of F? Okay, what is the value of F? So we are going, since it is horizontal, we can think of equilibrium. It is uniform, the weight is at the midpoint. It is a uniform rod, so the weight is at the midpoint. Okay. So let me resolve f vertically so that I can easily consider the distance from point x to y as the perpendicular distance. So resolving f vertically will be f sine of 30. So the perpendicular distance of f sine 30 is x times xy. So taking moments about point x, I have that f sine of 30, that is the force, times its perpendicular distance, which is xy, should be equal to, this is going to cause anti-clockwise moment and the weight is causing clockwise moment. So this should be equal to 10 newtons times the perpendicular distance. This is going to be a half of xy because this is the midpoint. So times a half of xy. Okay, so xy cancels out, and that means f equals to a half of xy, 10 divided by 2, that is 5, divided by sine of 30, which is 10. So f is going to be 10 newtons. So the answer is C. The diagram shows two fixed pins, Y and Z. A length of elastic is stretched between Y and Z and around pin X, which is attached to a trolley. Okay. X is at the center of the elastic and the trolley is to be propelled in the direction P at right angles to YZ. The tension in the elastic cord is 4 newtons. So the tension here is 4 newtons. So the tension here is 4 newtons. So this is the tension, 4 newtons. The tension here is 4 newtons in that direction. Okay. So let's first find, I will draw a horizontal line here. What is the force accelerating the trolley in the direction P when the trolley is released? Okay, so if there is tension here, I'm going to resolve this tension in the horizontal, and I think it will be T. The tension here in the horizontal is going to be 4. I'll put an angle here, let me call it theta. Of course, it will be the same angle here. So we have two forces here. We have 4 cos theta plus 4 cos theta. That is the force we are looking at. So the force we are looking at is 4 plus, that is 2 times 4 cos theta. That is the force we are looking at. All we need is to find theta. So if this is a horizontal line dividing this, so this is going to be 40 millimeters. And this is going to be 40 millimeters. So I have a triangle. Let me pull out a triangle, a right angled triangle where this angle is theta. And this is 40 millimeters. And this is 50 millimeters. So I want theta. Opposite hypotenuse, that is sine. Opposite hypotenuse, that is sine. I'm going to use Pythagoras theorem to find this one here. So let this be A. So A is going to be the square root of 50 squared minus 40 squared. I'm using Pythagoras theorem to find that side. So 50 squared minus 40 squared. And of course, if I find the square root, that is 30. So A is going to be 30 millimeters. So this side is 30 millimeters. That means cos of theta is the same as opposite, which is 40. No, cos is adjacent over hypotenuse. So that it will be 30 millimeters divided by hypotenuse, which is 50 millimeters. So cos is 3 over 5. So I'll just say F is going to be 8 times where there is cos theta, I'll put there 3 over 5 because this one cancels. So times 3 over 5. So 8 times 3 divided by 5. That is 4.8. So this is going to be 4.8 newtons. So the answer is going to be C. Remember, I crossed out these zeros. I remain with 3 over 5. Two solid substances, P and Q, have atoms of mass MP and MQ respectively. They have NP and NQ atoms per unit volume. The density of P is greater than the density of Q. What must be correct? Okay, first of all, we know that density is mass divided by volume. Density is mass divided by volume. And let's start with P. The density of P should be the mass of P divided by the volume of P, which is going to be the mass of P divided by. They told us they have NP and NQ atoms per unit volume. So it means volume is equal to 1 over the number of atoms. Number of atoms. The volume is going to be 1 over the number of atoms. So it means, because they say they have NP and NQ atoms per unit volume. Per unit volume. So the total volume is going to be 1 over the number of atoms. So this is going to be NMP over 1 over the number of atoms for P is going to be NP, which means this implies that the density of P is going to be MP times the number of atoms. Then similarly, it means the density of Q is simply going to be the mass of Q divided by 1 over the number of atoms for Q, which means the density of Q is going to be the mass of Q times the number of atoms for Q. Okay. So let's check. Two solid substances P and Q have atoms of mass MP and MQ respectively. They have NP and NQ atoms per unit volume. The density of P is greater than the density of Q. So it means M, P, N, P is greater than M, Q, N, Q. So the answer here is automatically going to be C. M, P, N, P is greater than M, Q, N, Q. So the answer is C. A ruler of length 0.3 meters is pivoted at its center. Equal and opposite forces of magnitude 2 newtons are applied at the ends of the ruler. Remember, it is the 0.3 meters. Creating a cupola as shown. What is the magnitude of the cupola? So we just need the perpendicular distance between the two forces. Product of one of the forces and the perpendicular distance between the two forces. That is going to be a cupola. So it is, since this was pivoted at its center, it means this length here is 0.15 and this is also 0.15, the length here. Or maybe when I write inside, people will think I'm referring to this one here. No. This length is also 0.15 in meters. So I'm going to try and find this distance here, which I'm going to call D, from here up to here for that triangle. So this is opposite hypotenuse, that is sine. So sine of 50 is equal to the opposite over the hypotenuse, which is 0.15. So that means D is 0.15 sine of 50. So to get the total distance, I will multiply that by 2. I'll multiply this distance by 2. So perpendicular distance is going to be twice that. So total is going to be 2 times 0.15 sine of 50. That is total distance. So I want the magnitude of the torque of the cupola. So the torque of the cupola is the product of one of the forces, which is 2.0 newtons, times the perpendicular distance, which is 2 times 0.15 sine of 50. So I'll press my calculator. 2 times 0.15 sine of 50. So I'm getting this as 0.46 Newton meters. So the answer here is going to automatically be C. The diagram shows a child is balancing game. The wooden rod is uniform and all the rings are of equal mass. 2 rings are hung on peg 13 and 1 on peg 1. On which hook must a fourth ring be hung in order to balance the rod? Okay, so on which hook must a fourth ring? So let's say it is balanced, it is placed at a distance x. Let's first find the distances here. So 2 rings are hung on peg 13. So these are 2. And this distance here is 13 minus 8, which is 13 minus 8, which is, I think this is going to be, that is what? That is 5. 5. And on the left hand side, we have 1 ring is on peg 1. So we have 8 minus 1, which is 7. So here we have 1 ring, and here we have 2 rings. So on the left hand side, we have 2. Let's say the mass of each ring is m. Let the mass of each ring be m. So here we have 2m, and here we have m. So on the right hand side, we have 2m times perpendicular distance, which is 5, should balance with the right hand side, where on the right hand side we have m times 7. So since on the right hand side we already have 10m, and on the left we have 7m, so it means the other one should be on the left. So plus 1 ring, because on which hook must the fourth ring? It is 1, to make them total 4. So its mass is m times its distance, which we don't know. Let me call it y. So of course m cancels out, so you have 10 equals to 7 plus y. So y is going to be equal to 3. So y is 3 from the center, from the pivot. So from 8, on the left we have 1, 2, 3. So y is 3 from the point, from the pivot. So it means the answer is going to be 5. We place it at on which hook? So on the 5th hook. So that this distance here is 3. So the answer is going to be C. 2 possible displacements of an object are represented by the vectors P and Q. Okay. Which vector, so this is a repetition, which vector best represents the resultant displacement P minus Q of the object? Which vector best represents the resultant displacement P minus Q of the object? Okay, so I will try to reverse. On the head of P, I'm going to reverse Q so that it points in the opposite direction. So this is going to be minus Q, negative Q. So the resultant, let me call to Y, should be equal to P minus Q. In other words, Y plus Q should give us P. So if I draw another line here, so if I join P plus minus Q, then this one should be in this direction here. So that P plus minus Q is equal to Y. So I think this makes sense. So the resultant is going to be like this. So the resultant must point somewhere this side. So this is going to be wrong. This is going to be wrong. and this is going to be wrong. So this is going to be the most appropriate value, because when I reverse Q to point in this direction, the resultant should point to the other side. So it means the most appropriate value is going to be D. A horizontal plate of area 0.303 meters, 0.036 meters cubed is beneath the surface of a liquid of density 930 kilograms per meters cubed. The force on the plate due to the pressure of the liquid is 290 newtons. What is the depth of the plate beneath the surface of the liquid? Okay. First of all, we know that pressure is force divided by area, and pressure is density times G times difference in height. So the force is 290 newtons divided by the area, which is 0.036, equals to the density, which is 930, times G, which is 9.81, times H. Let's find H. So 290 divided by 0.036 divided by 930 times 9.81. So H is 0.88. H is 0.88 in meters. So the answer is going to be automatically A. A vector quantity V is resolved into two perpendicular components x and y. The angle between V and component x is theta. Okay, the angle between component x and the vector V is increased from 0 to 90. So we increase this angle from 0 to 90. When it is 90, V is parallel to y. When it is 0, V is parallel to x. How do the magnitudes of x and y change as the angle theta is increased in this way? Okay, so first of all, x, that is the component in the x is going to be resolving V to the horizontal along x, that x will be equal to V cos theta, and y is going to be V sine theta elsewhere. So they said theta increases from 0. So as theta increases, what happens to cos theta? Cos theta decreases. And what happens to x? It means x decreases. So as theta increases, x decreases. So we ignore A and B. Then how about theta? How about sine theta? As theta increase, what happens to sine theta? So as theta increases, sine theta also increases. And this means y also increases. You can check with your calculator. The cos of 0 is 1. That means when theta increases from 0, cos of theta decreases because the maximum is 1. So sine theta increases. So the answer here is going to be C. X decreases as y increases. An object immersed in a liquid in a tank experiences an upthrust. What is the physical reason for this upthrust? Physical reason for this upthrust. We know that upthrust is equal to cross-sectional area times difference in pressure. So the upthrust is the difference in pressure, and we know that pressure is equal to density times G times difference in height. So pressure changes. The change in pressure is due to the change in the difference, the change in the height, the depth. So pressure in the liquid increases with depth. So the answer is automatically C. Pressure in a liquid increases with depth. The depth at the top is not the same as the depth. The pressure at the top is not the same as the pressure at the bottom. Okay. Atmospheric pressure at sea level has a value of 100 kilopascals. The density of seawater is 1020 kilograms per meters cubed. At what depth in the sea would the total pressure be 110 kilopascals? So we have already seen that the difference in pressure is equal to the density times G times the difference in height. So the difference in pressure is going to be 110 minus 100. And I'll multiply this by 10 power 3. This should be equal to the density, which is 1020, then times G, which is 9.81, then times the difference in height, or the change in height. So I will just press my calculator. Of course, this is going to be 10 power 3, 10 exponent 3 divided by 1020 times 9.81. So I'm getting the difference in height as 0.99938, which is approximately 1.0 meters. So at what depth is this in the sea would the total pressure be 110 kilopascals? So the answer is going to be A. Okay, so let that mark at the end of part 10, and see you in part 11. And I hope part 11 might be the last, if not the last. So see you. Bye bye.